Hi, folks. Well, if you got everything set up right, you should have your motor coming off of pin 8 and then going to the ground bus bar. And your potentiometer should be set up so that the signal pin is the middle one going to A0, analog N0. And then one side is going to ground, and then the other side is going to 5 volts input. It makes no difference on which side the 5 volts and the ground are, as long as the analog 0 is in the middle. And when I turn on the uh, potentiometer and bring it up above the threshold that we had set at 400, it indeed goes on, and then when we turn it back down, it shuts off. So let's see what's happening on the serial monitor. We are below threshold at 354, and when we shut it back on, that is the motor back on, it's because we've gone above 400, and then it goes back off as we go below 300. Remember, mine once again, our highest value possible is 1023, and our lowest value is 0. And that is how Arduino chops up the 5-volt signal that can go in. All right, so let's take a look here at the actual sketch that we did. Once again, we had our initialization stage before void set up, and that's where we declare our pin values and name them. Analog pin is A0, and we put it as an N or constant N. It really doesn't make a difference in this case. You can do either. The motor is on pin 8, and the threshold value is assigned at 400. So whenever we see the word threshold later in the sketch, we know that that means 400. Setup stage, once again, void setup is where we declare our things that are outputs, in this case the motor, using the pin mode command. And we also set up for the use of our serial monitor with setting the baud rate, serial.begin 9600. It's very doubtful any of our sketches this semester will change that value. Then we come to the void loop stage, open up that bracket one more time, and that is what the Arduino will be doing over and over again as long as the power is on. We've set our analog pin to where it will be read with the analog read function. And then our if-else conditions. If the pin is above threshold, in other words, if our potentiometer is dialed up above 400, our motor goes high, digital write motor comma high. Otherwise, he just stays low, which is the same thing as on off. That is digital logic. You're either high or you're low. You're either on or you are off, ones and zeros. And even though it's not necessary to get the motor running, we like to see what's going on in terms of the values that we're dialing in. So we tell Arduino in the loop stage to print the analog pin value and give it that 1 millisecond delay to make sure that it delivers the signal smoothly. Okay, let's try something else. Okay, why don't we give a shot at seeing if we can get our potentiometer's threshold to govern which of two LEDs comes on. So pull off the motor and replace that motor on pin 8 with a jumper going to the long leg of an LED, and then complete the circuit for that LED with the 330 resistor going to ground, and add a whole nother LED resistor setup on pin 9. The potentiometer setup will stay the exact same. We have a side pin going to ground, middle pin signal A0, analog N0, and then another side pin going to 5 volts. And what we'll try to do is to see if we can tweak this sketch that we've just done to where we have an if-else logic that makes the number 8 LED pin come on if we're above threshold, and the other one is off. Else, the pin 9 LED is on and the pin 8 LED is off. So we're still would be using if-else statements, but we now have reset the conditions to where we have two outputs, one going high while the other goes low, else the second one goes high and the first one goes low. So see if you can get a sketch to work that way. A lot of the fundamentals in the previous sketch should be exactly the same. The main thing is that you are changing identities on pins 8 and 9, where you're adding an identity for pin 9. You need to declare what they're going to do in the setup, and in the loop you need to make your if-else statement reflect what you want to do, which is alternate which LED is on or off, depending on whether you are above or below the threshold with your potentiometer. You can reset the threshold on the potentiometer from 400 something else if you want to, or just leave it the same. So put on your thinking caps. Let's see if you can get it done. Pause this video, and when you think you've got it right, let's see how you did. Well, this was a way to do it. We kept our analog pin declared at A0. We didn't, because we didn't move that around. So in our initialization stage, that stayed the same. But our two outputs have to be declared also, pins 8 and 9. And just for fun, we decided to give our LEDs names cat and dog. We could have said LED 1, LED 2, but figured, oh, what the heck, just have fun with this and give them some other silly name. The main thing is, once you name them in the initialization stage, it has to stay the same throughout the rest of the sketch. Our threshold, I decided just to keep mine at 400. That's fine. You may have changed yours. Then we moved on to the setup stage, where we needed to declare our two pins as outputs. So pin 8, which we call cat, is an output, and then pin mode, pin 9 dog, he's an output. And because we are going to use the serial monitor, we kept that serial begin 9600 baud rate in the sketch. So close those brackets. We're now in a new void. We're in our loop, the actual part of the sketch that runs over and over again continuously as long as power is on. Our analog value being read under the analog read function stayed the same. We still have an if-else statement where if the value is above threshold or otherwise it's not, but instead of having the motor high and low, we have our two outputs. In this case, pin 8 is high and pin 9 is low if we're above threshold, that greater than sign. Else, if we're below the greater than sign, 400, pin 8 will go low and pin 9 will go high. Cat will go low, dog will go high. We don't need to have serial print for this sketch to work, but we want to see how it's going, so we have that serial print LN analog value function written in, and we have our delay of 1 millisecond to help smooth out the signal appropriately. And so that is a way of doing this. And so if yours seems to work, then just be happy. Let's see how the one we did worked out. And indeed, we've got our if-else logic working here. As the potentiometer rises above the 400 threshold, my LED at pin 8 is going high. It's my yellow one. And then when I turn the dial to the right, and we have go below threshold of 400, our LED 9 comes on and the LED 8 goes off. So high, low, and this is a great example of if-else logic. And these two sketches that we've done really do well to illustrate the analog to digital function of Arduino. We're taking a variable signal, which is the potentiometer, and turning it to a digital signal. This is analog because we can turn the dial, run and force the Arduino to run between 0 and 5 volts if it's possible read value, because that can change from 0 to 123. It's analog. We could replace this with a temperature sensor or photodiode, just any sort of variable input resistance. And what we have over here is output that is digital, because you're either on, off, high, low, ones and zeros. And this is the core of so much of what Arduino does. And we'll see this again and again in different ways, both in our project sketches and any sketches that you may want to do for fun. So hopefully you got everything running, and we're getting a better understanding of what belongs where in the initialization, void setup, and void loop phases of our sketches. What you may want to do is check out Sketch 7 in the SparkFun Inventor's Kit guide, which is where you have a temperature sensor printing out the temperature in Celsius and Fahrenheit, and see if you can tweak the sketch like we did here and use a set temperature of your choosing to shut on and off a certain output. We'll have another quick video coming up on that pretty soon if you want to explore that as an option, and I hope you do. And if you're still having trouble, as always, check to make sure that you've got everything running ultimately to a common ground. It's not very easy to put something in the wrong pinhole and not complete your circuit. On the sketch end, if you're having problems, you'll see that you'll start noticing that certain errors that are at the bottom tend to be associated with certain mistakes. And we'll have a tutorial in a few days where you figure out how to fix some of the common mistakes that you may be running into as you learn the Arduino platform.